very much. My name is Okada. Today, I wanted to introduce you to our activity of Q-Star. So Q-Star, 2 years ago, it was established. Today, the message that I have to you is that through this activity, the quantum technology, actual implementation towards using this in the industry, I want you to experience firsthand that, in fact, we're making progress in the implementation of the quantum technology. So, about Q-Star. As I had mentioned earlier, 2021, September 1st, Q-Star was established. The purpose here was to create industries and businesses based on quantum technology. Therefore, this is not where the technological development is going to take place. However, this is a place where to give benefit to various parties in using the quantum technologies. I would like to explain about this later on. About industrialization, there are various global organizations. We are collaborating with those international groups and organization institutions so that we will be able to realize the implementation of the quantum technology. So we've started off with the 24 member organization, and right now we already have, as of today, 84 member organizations. Main activities as listed here. What the government has announced we have participated in the review working group to create vision to quantum future society. And furthermore, I'd like to explain about further in this presentation. We have been able to introduce and discuss about 50 use cases and what area can we implement. And through this discussion this year, coming into this year, we are currently trying to narrow them down and try to identify what candidates. So now let's talk about what is quantum technology. In Q-Star, we are trying to understand quantum in a very wide areas and scopes, and materials, quantum materials, and furthermore sensing and also devices and materials using quantum technology. Those are also in our scope. Out of these 84 organization members, about half are the user companies. In fact, more than the vendor company who are to provide quantum, we have the actual private companies participate in this Q-Star as member organization. So this is the goal of Q-Star. What I have stated right at the top, this is based on the vision that was announced from the Japanese government. This has been also been stated by 2030. We want 5 to 10% of population to be using quantum technology without them knowing. So for that, we have to really strengthen the technology. And furthermore, we have to make this into an industry. In other words, we have to make it into a business, or else we won't be able to fund ourselves. So to create the business is the key word here. So in this session, I'm sure this is going to be mentioned. But to do that, fostering capable individuals are very important. And furthermore, working together with academia and government collaboration need to be realized. We are here to coordinate that to happen successfully. So what we are doing specifically then, main thing, as you can see here, subcommittee, what we call the subcommittee. These are the main efforts that is taking place. We want people to participate in the areas of interest in order to discuss about how could they use quantum technology. So that is our main area of activities. And furthermore, we are looking into educating and fostering capable individuals. And after the patent, intellectual property has been declared, what will happen after that, and also other areas of consideration areas, what are they? That is conducted in the Q-Star activities as well. And furthermore, what I would like to introduce is that QRAMI. This is a reference architectural model. this looks a bit complicated to you, maybe. However, for what purpose, why we have created this, let me explain that to you. I have talked about quantum technology up until now. However, when talking about quantum technology, which aspect of what are you talking about in terms of quantum technology? Depending on each individual, the definitions are varied. We started to realize about that. So which business and what problem are we focusing on? So in order for us to streamline our thinking, we put together this reference architecture. This came from the Industry 4.0 from Germany, RAMI 4.0. Basically, that is based on that, this QRAMI. So here, what we did was that we tried to identify which domain is this going to be used. And also, we also have a hierarchy, devices, modules, and also computing, sensing. So each of these hierarchy has been defined. And what's most important is this architecture area. Right at the bottom is the asset layer. In other words, in which foundation, which technology specifically. So if you can integrate multiple of these assets, and furthermore, there will be a communication, and on that data, the functionality, and the most important thing is what is the challenge. So starting off with the top challenge to access to the asset, how could we all link this together? What we that is what this has put together. So now this technology could not be used alone. So if we try to use this, the front may be the PC, the back network may be the basic PC network. So those existing technology and also the quantum, how will those be combined could be made clear using this. And furthermore, quantum computing, gate computer maybe takes 10 or 20 years to come. So when the new technology comes about, which asset will be replaced? That could be discussed using this architectural model. So for that purpose, we created this architectural model. So use case, in what businesses are we to use these areas? When we have that discussion, this asset model, in replacing this as architectural model, we try to define. So by that, when we actually do the implementation, we can have a thorough discussion which doesn't get swayed with different aspects. And now, since I don't have so much time, I would very much like to only touch upon the subcommittee area. First, this application of quantum wave and quantum probability theory. This all started from the financial sector. What's very important here is backcasting. In actual fact, against the challenge that we have, what the 2B picture is going to be. So from that 2B picture, at which stage? Here we come, the QRAMI, the middle. Which part of QRAMI are we to use to actually implement is what we're to discuss. So with this backcasting model, the use case was that power consumption optimization. So for example, this is actually the current society using the, creating the power and optimization. What will happen using this backcasting? It's be renewable energy 100%. And in this renewable energy 100% environment with the existing grid, it is going to be so much of a combination of optimization necessary that could not be calculated only with grid. So at that time, quantum computing is definitely going to be a must and necessary. So in between, we have to think about the combination. So this backcasting and also the transitioning, how to be able to successfully transition, that realistic discussion we're to do. And furthermore, we have the use case of application of a quantum superposition. So we're going to make use of this quantum technology, quantum superposition technology. So currently, we're trying to deep dive into the use cases. So this is an example of using this in the chemical computation, quantum chemical computations, and what could be done with QRAM. Is now tried to be explain in this slide. So main slide, what will be the closest to implementation? The optimization is probably the closest to actualization. Thinking about the annealing, digital annealing technology. which is very characteristic of Japan. How to be used that is one of the use cases. This area also, we have been able to thoroughly discuss on this area. And in fact, I would like to explain the actual use cases which we have been able to implement. When we want to make this into implementation, if you could look at this slide, in Japan, Fujitsu, Toshiba, NEC, Hitachi, and Fixstar, these Fixstars are doing the annealing engine. And on this engine, there will be the intermediary gateway in the middle, and if something happens in all engine, we'll be able to come up with an answer. We have created that software layer, and because of that, the good aspects of these annealing machine could be utilized. So that is what the QStar and Nedo has been creating so far, and as a result of that, this is the most immediate use cases, 6 use cases that we have been able to identify. So I would like to explain to you about 3 examples here. The large-scale material exploration. If you will be able to look at this here, for example, certain modeling the current existing HPC will do, and for the optimization and annealing will be used in this model, in this use case. So we've done this actually, and in terms of exploration, 11 parameters, when there are 11 parameters, the data was over 16 million, then the existing algorithm will be transferred with the annealing machine, and in fact the speed will be accelerated and higher. So in other words, if it's 16 million or more, we will be able to utilize the advantage of the quantum. So on another aspect is when we're using this annealing, one of the biggest challenges that we have to convert to qubit, and we have to have engineer who are good at mathematics and who have this mathematical sense. And we will be using the machine learning and giving the machine learning and giving the machine a question, we can be able to get back an answer right away. And that is really innovative. Of course, we need to do some tuning, but in this kind of cases, we have been able to create an environment where people will be able to use this at ease. And another is the insurance premium. When there's an insurance portfolio, there's a risk distribution. We've also conducted risk distribution with this. And this example is here. This is the Hitachi Siemens annealer and Toshiba's SQ annealer. This is both has done this, and this is the current insurance portfolio. And against that, if you will be able to see the very high and high profitable portfolio could be identified here. So there's already immediate use case that could be used right away. And next, let me talk about the network. And there are also various other use cases here. So for the route analysis and also to be able to optimize the people's driving, obviously route selection will be necessary, and that person's vital data, the driver's vital data will also be necessary. And furthermore, it has to be in real time. And these things could be done in a secure manner. And we are trying to consider where that could be used in the most optimal manner. This will be the BPO services, business process outsourcing. Maybe in your organization or your institution may use BPO, and may have an opportunity that you have to disclose secret information. And in fact, we will be able to make use of QKD. So when you do an M&A, for example, you will have to bring out information of the company, and that will be secured in the virtual data room. Those will be secured for several decades. And in order to secure those confidential information, this quantum technology, quantum safe virtual data room could be used. And furthermore, another use case is quantum city. People talk about smart city nowadays and trying to once again reorganize the city. And by using quantum, they are trying to optimize that at the city level. There's going to be a lot of EV. And to optimize the EV and also using EV, saving electricity is also could be conducted in a most optimal manner. For example, the taxis becomes EVs. And in order to optimize this, if there are 7,000 so many of the taxis, the calculation will be too much. However, in those areas, the quantum computing could be used. And in fact, 11 people have also started to look into this area. And the most newest subcommittee is the sensing area. This could also make use of the characteristic of the Japanese technology, the high sensing technology. And what you see in the middle is using the optical lattice clock network, the very precise to understand the geography of those areas, and also in the areas of improvement of sensitivity and diffusion of MRI, these quantum materials and devices sensing could be used. And I have introduced some of the example of how this quantum is being implemented nowadays. And this is called the Japanese Quantum Secured Metro Network Project in 10 locations, including Otemachi. Currently, there's a secure environment, and in fact, this fall, this is going to be completed. So by using this network, the various applications could be implemented. Already, several of the government organizations have started using, and that is going to be open to the industry as well. So in fact, several of those companies have already raised their hands to volunteer. So apart from China, we have been able to create the largest quantum network in the world. However, quantum technology can't operate on its own. It has to have work together with the classical environment as well, classical quantum hybrid environment. So using the existing classical computer and also using the quantum computer together, that environment is going to be established as well. At the ICE, there was a talk from Horibe-san, and together with the Q-Star member, we very much would like to use these cases so that we can actually create use cases. I talked about collaboration with global networks. In fact, this year, there was a G7 summit taking place. And part of that, there was a G7 Science and Technology Minister meeting in Sendai. And there was a discussion about how to be able to use the quantum technology. And we have been able to participate, Q-Star, QRG, and Europe, QEC, and QIC of Canada. We have been able to work together. And with these 4 organizations, we have been able to present. And towards implementation, these are the activities that we are trying to provide in a global manner, so that we will provide an environment where people will be able to implement quantum. So we want to create the movement. That is the mission of Q-Star. If we were to use this quantum technology, we have to make sure that this is made into an industry. So I myself, what I believe is a challenge right now, is the very fact that the quantum technology, there was a lot of expos and exhibitions today, this morning, and also in the morning discussion, there was also been mentioned. There's not quantum technology, so many quantum technology that we can use right away. And there's going to be a lot of technology that's going to take some years to come for the development. So if we sort of don't do anything here, the industry is not going to foster or grow. So as I showed you in the annealing example, we ought to start working from what we can use already and be able to show the benefit and prioritize what we can use right away. And by that, we can secure the funding, and we will be able to continue the research, and we will be able to further our development. And also, the benefit will be leaped from the benefit will be greater for those who have adopted earlier. So this is the areas in which where the quantum technology could be used in society. So through Q-Star, together with you discussing, we hope to be able to realize the quantum technology in these areas. So in fact, there's already a Q-Star booth in this venue. So for those of you who are interested, please come and visit. And furthermore, of course, it is very important for you to become members of Q-Star. But even not, I believe that we will be able to collaborate very much with the members of academia and also with the people overseas. So I hope that you will be able to speak with us since this is a great opportunity. So without being very shy, please speak to us. So that's all from my presentation. Thank you very much.